Team Strathloop. So yeah, let's get started. I'm just first just gonna introduce y'all. So welcome to the Hearttex Funds Hyperloop Symposium. Thank you for everyone for coming. And welcome to weekend 2 of the symposium. My name is Samar Sandeep, and along with Linda Huang and Kirk McGregor and Blake Annenberg, we all run the Hearttex Fund. We're trying to help promote the creation of new Hyperloop collaborations. So in that spirit, this weekend we're going to be doing a couple of sessions on how to scale up Hyperloops and highlighting some researchers who are working on work related to scalability, as well as having panel sessions to discuss that in more depth. So today is the day where we're going to go through those lightning talks and watch those presentations, and then tomorrow we're going to go into more panel discussions. So first up, we're going to have Team Strathloop. They're going to be talking about their airlock system design, as well as the energy efficiency of their onboard energy system. And then we're going to have Kalrav Shah, who's a master's student at ETH Zurich and was a master's student at Delft, who's going to talk about his pioneering design of a Swiss Hyperloop network design. And then we're just going to have a Q&A session and continue to discuss new changes we've seen in these kind of feasibility studies over the last year or so. So if Team Strathloop would like to begin, please share your screen and take it away.
Wonderful. Get up.
I can still see Kalrav's screen at the moment.
I should stop, right?
If you don't mind, thank you.
Yeah,
here we go. Okay, Brad.
That's
yeah.
Oh, there's a pop-up. Give me a second. Cool. Can you see that on you?
Yep.
Right. Hello, everyone. I'm Brad. I'm the body and aero lead from Team Strathloop. We're a student-led design team from University of Strathclyde in Glasgow. And as we said, I'm just going to talk about our airlock system design. So basically, the airlock system is a very fundamental part of full-scale implementation. It's used to maintain the boundary between station, pod, and tube. And in addition to allowing passengers to safely transfer from the station into the pod. Now, there's two main challenges faced with making that system. And the first is the technical challenge of reducing pump times and pump costs. And the second is providing a seamless user experience for passengers using this. Now, the general solution to both of these problems is essentially trying to minimize the volume of the chamber that you're using. And for the sake of this study, we've used a very kind of top-level comparative approach, just to get an idea of the differences between the general concepts. And then in the future, there will be more specific technical work done on each of these concepts, or the one that we choose to pursue. Now, the four that we've assessed is twin chambers and single chambers, which are kind of traditional airlock chamber solutions. And then there's two more novel approaches in the indoor and the bridge solution. So the first list, the twin chambers, is essentially we'll have an airlock chamber at each end of the station, which can transition between the tube and station pressure. And then the pod will simply pass through that and stop in the middle of the station, allowing passengers to exit that way. Now, the biggest benefits of this is a very fast, familiar boarding procedure for passengers. And that leads to a very high perceived factor of safety as well. In addition to that, it's obviously quite a familiar layout and it can be implemented into stations quite easily. The biggest disadvantage with this method is a starkly large cost in time and money to pump down these airlock chambers. So for each cycle of a pod coming through, you've got to pump each airlock with the pod in and each airlock without the pod in as well. And given the time it takes to do that, it leads to a much larger station because you have to have more of these airlocks for a given number of pods coming in. Now, to solve that, basically, you can adopt the single airlock chamber approach. seems quite simplistic, but it's a drastic change. So through doing that, you still maintain that same familiar boarding procedure because the pod's in atmospheric pressure and passengers can basically step in and out like a normal train. But it comes with the fact that you're now halving that number of cycles of the airlocks for each pod coming in. In addition to that, you never pump this airlock without the pod in. So it's a huge saving, more than double, I'd imagine, in terms of cost and time to pump. In addition to this, you can have much smaller stations because you don't need those hundreds of airlocks for a given number of pods. The only downside to it is if a compressor is utilised in the front of the pod, you will need some sort of mechanism in the station for the pod to turn around so that it comes back into the airlock. The compressor is still at the front. So for both of these methods that use a chamber where the pod completely exits the tube, it makes sense that the doors that these passengers are entering and exiting from are as large as possible from a passenger flow perspective. But given that the pressures are so large in this environment, there might be a lot of difficulties in terms of structural with these large doors. So it could pay to look towards kind of proven technologies for these kind of things. Things like plug doors in aircraft, or if you look at industrial approaches, you have the big like O-ring seal end doors, which leads us into the first of our novel concepts, which is the end door airlock. So that utilizes that end seal, and it basically means the pod can approach the end of the tube and lift up and dock that way. Now, the advantages of this is that it completely eliminates any pressurization process. So massive saving in time and money. And it's a very simplistic infrastructure. There's no extra chambers or anything like that required. It does come with disadvantages though, that this whole docking procedure is unproven. It's not been tested or done. There's no data on it. So it's an avenue for future work to assess the time that it would require for a system like this to dock, because it may end up being more time consuming than simply pumping a chamber. So it's a big avenue for future work, that really. In addition to this, with the end of the pod lifting up, it could inhibit the performance of the compressor on the end. So that's another avenue for future work. It leads us into the last of our concepts, the airlock bridges, which, like a commercial airliner, you'd imagine kind of bridges coming out of the side of the tube, docking with the pod. They'll pressurize, depressurize, and let passengers transverse between those two. Now, once again, you don't use a large airlock chamber, which may reduce time and cost the pressure pump to pump these pressure vessels. Once again, though, you do have a very complex docking procedure that we can't really analyze and compare to the regular chamber solutions. And similarly to the other one as well, actually, you never see the pod, which could affect passengers' willingness to uptake this concept, both from a safety perspective, because you're not seeing what you're traveling in ever, but also just because passengers may want to see this cutting-edge technology, and that may encourage people to actually want to use this service in the long run. So all things considered, with the data we have at the moment, the single airlock system does seem to be the most reliable and useful. It's slightly disappointing maybe because some of the fancier solutions are quite smart, but with the data we have, this does seem to be the one to go for. Like I say, you'll need some sort of mechanism for the pod to turn in the station if the compressor is used. And also, as I was saying, if we'll probably aim to do some future work into analysing these specific docking procedures, just to have a more thorough comparison, and that's something that we will aim to do in the future. And in addition to that, the opinions of possible users or other people on not seeing the pod ever is quite valuable to those other procedures, so it's something that we could maybe do some research into, and maybe tomorrow or later today, getting you guys' opinion on that kind of thing would benefit that as well. And that's it. Thank you for listening. I'm happy to take any questions.
Yeah, nice consideration of a lot of the effects of each piece. I think one more thing that I would throw out there is thinking about the effect of the load on the vehicle from each of the different pieces. That's something that we've kind of thought a lot about at Virgin Hyperloop. So hit a lot of the good points though, and I think that people don't think enough about the passenger perception. So
Yes.
the fact that you guys spent a lot of time thinking about that is pretty astute.
Thank you.
Of course.
Yeah, so I'm Kirsty and I'm the Power Systems Head for Strathloop as well. And our project has been on the eco-sustainability of power systems concept. So I'll just go right in. So yeah, I'm the same as Brad. I'm also from Strathloop, which is University of Strathclyde student-led. But yeah, I'm head of Power Systems sub-team. So the whole idea behind this project was to research ways in which Strathloop's pod design could be more eco-sustainable, but also to look on the wider scale of how Hyperloop can be more environmentally friendly, as well as looking into how eco-sustainable batteries in general are. So some of the research covered in the project was, we looked into types of batteries, specifically lithium-ion batteries, since that is what our power systems team had decided before the project. Looked into battery disposal within UK and out with UK. Renewable energies was a big thing that we looked at the end. Second use batteries. Changing cost of lithium-ion batteries, which seems to be getting better as years go on, which was a good thing. And the charging time of lithium-ion batteries and what this affects, especially when it comes to Hyperloop, because obviously we want things to be fast and things to be charged fast, and sometimes that can actually affect the battery in a bad way, and we looked into if there was ways that that can be minimised. So the biggest issue within batteries in an eco-sustainable way is definitely disposal of batteries. So first of all, there's no disposal units for lithium-ion batteries in the UK at all. Our closest disposal unit for lithium-ion batteries is in Belgium. And even at that, the way we dispose of batteries isn't 100% environmentally friendly. The two main ways in which we dispose of batteries is pyrometallurgically and hydrometallurgically. Pyro is not very good for the environment at all. It uses high temperatures, high energy, high metal loss. So if we're trying to actually reuse the substances and stuff from the battery, you're not getting a lot back from that. Hydrometallurgical is better. It's definitely the better of the two processes. Recycles 80% of the battery, but it generates chlorine into the atmosphere, which in itself isn't particularly great. So for us, we came to a few conclusions. For Strathloop's pods and our power systems specifically, in order for us to improve the sustainability, we've investigated the practicality of using second-use batteries. So what this is that once a battery is used, you can get this battery again to 80% of its previous capacity and use it. So we're looking into how ideal that will be for the Hyperloop competition, because obviously with costs and stuff, we need to look and see if that's actually ideal. However, for an environmental side, that is probably the best way forward. For the whole of Hyperloop, incorporating renewable energies into Hyperloop concepts, for example, solar panel arrays or wind turbines, this is location dependent. As we are based in Scotland, solar panels isn't probably the best for our pod. For our pod, definitely wind powered would be the best, or tidal powered. However, if you were somewhere like Iceland, if you had a way of doing that from biothermal energy, that would be excellent, which is how they actually do power a lot of things over there already. It depends on if we're using a tunnel or not, if we're underground, etc., to how well solar panels would be overall. And then further development of battery disposal and waste management as a whole for batteries in general. definitely needs work done. Even for hydrometallurgical, which was the best process we found for the disposal of batteries, it can be improved by using more organic gases, and using chlorine gas, which itself has its own issues, I know, would stop the chlorine from actually escaping into the environment. And also with a lot more like manual labour and stuff, you could actually recycle 100% of the materials instead of just 80%. But that is the conclusions that we came to from this project. So if anyone has any questions on that, they can let me know.
Were you able to find any information about kind of where the industry is heading on the recycling? I know there's a lot of focus on batteries that last longer or have more energy density, but I haven't seen much in this direction.
Yeah, for the actual recycling of batteries, there doesn't seem to be a lot of research, at least in the UK at the moment. For well, the fact that we actually don't have any lithium-ion disposal in the UK at the moment is quite bad in itself. But yeah, I think they're definitely more focusing on other things such as making batteries last longer or having better charging time and stuff.
Makes sense. Thanks.
No problem.
Okay, thank you so much, Kirsty and Team Strathloop for your presentations. And again, if you have any questions, please feel free to ask in the Zoom chat or on Slack as well. Now we're going to hear a presentation from Kalrav Shah from Delft University and ETH Zurich, who's going to talk to us about his design of a Swiss Hyperloop network. Kalrav, you have the floor.
Yeah, I think you can hear me. I just have to share the screen. Can you see my screen now?
Yes.
Cool. Yeah. So basically, as he already mentioned that my name is Kalrav, but I'm not at this moment. I'm not a student of either TU Delft or ETH Zurich. I did my master's from TU Delft. In collaboration between ETH Zurich and TU Delft. So it got finished almost 10 months back. You can see the date. So that's when I finished, and I'm nowhere connected to the field of transport at this moment. I left the field of transport on last December, meaning I don't work within the transportation industry anymore. But the thesis was carried out for around 11 months, being part of master's thesis. So I guess I have 10 minutes to talk, or 5 minutes, I'm not sure. What was it? Someone?
Yeah, go ahead and talk for 5 to 10 minutes.
Okay, cool. So I'll quickly, I wouldn't get into much more detail, but what I can show you is how I carried out the network design and optimization for Hyperloop network, and it was one of the initial attempts to actually look into the cost benefit analysis. I don't know if you are aware about what is cost benefit analysis, but basically it gives you the idea of whether an infrastructure project is feasible or not. So if the cost benefit ratio of the whole project is above 1, it means it gives you more benefits than the cost you incur throughout the life cycle of a project, which means it is positive to develop the project. And if the ratio is less than 1, then you can say that you have to incur more cost than the benefit you get. So you shouldn't go for ideally that project. And that's what I did for my thesis for the Hyperloop network. Since you all are from the background of Hyperloop, I wouldn't waste much time on introducing Hyperloop. But the idea, as I already said, that to design a network in a way which gives you the maximum benefit to cost ratio, which would have the maximum benefit overall the society, and which needs to incur the minimum cost for the government. However, I restricted this cost and benefits to the 6 parameters only, which includes infrastructure maintenance, operational. I think there's a spelling mistake over maintenance, but operational replacement cost, and the benefits includes travel time savings and the fare box revenue, which is for the government. To design a network, basically you need some input parameters, which input parameters basically deals with some assumptions like what kind of stations you're gonna have, what kind of lines you're gonna make, and what kind of passengers it gonna target, it gonna attract, whether it's gonna be long distance travel or short distance travel, that kind of stuff you need to look into. However, the thesis was restricted to the case of Switzerland, which is not a realistic case in real life, but it was an attempt since the data was available only for the Switzerland. So I envisaged the scenario of 2040 and had some assumptions how the cities will look and how the stations will look. So I chose 12 stations around Switzerland considering the population of the city, extrapolating for 2040. Developed some cost parameters throughout the literature review, a couple of interviews with some European student teams of Hyperloop, some European organizations, and even the Virgin Hyperloop one. I spoke to a couple of people. However, I cannot mention the names specifically here. This cost were This cost were available in 5 or 6 studies considering the different countries: Canada, US, Netherlands, Switzerland, and they have been developed during different years. So they have been extrapolated for 2040 considering the economical aspects of purchasing power parity and all that. And for 2040, unit costs were developed like for the stations, tunnels, foundations, vacuum pumps, solar panels, propulsion system, vehicle. It was also assumed that some staff would be required, a couple of people, how people will be how staff will be guiding to the passengers, and energy cost per seat was also assumed. We can discuss more about it if you are interested later on, but let me go through the network design process first. The third and so the first input you could see was the station, the second input you could see was cost, and the third design assumption or input was the demand. So I estimated the demand for 2040 scenario using the Swiss national transport passenger model. Developed a couple of scenarios as well. One scenario was without fare scenario, meaning there wouldn't be any specific ticketing prices for the Hyperloop. Since Switzerland have a national public transport subscription, I assume that the Hyperloop would be part of that subscription only, which says without fare scenario. While the second one says with fare scenario, was some ticketing pricing was assumed over that. We can discuss later on how it was decided and how sensitive it is to decide. In transportation planning, there are 3 steps to design a public transport network, which basically deals with the network generation, route design and frequency setting, and the assignment. So network generation basically decides between the stations which links should be built, whether a link should be built between point A and B, or it should be directly between A and C, how it should be connected. So I connected all the 12 stations to each other. You can see in this image, and then started deducting it and came up with the optimized network, which looks like something this. Also on the same network, I was now once the network was generated, I defined some routes. So for that also one of the algorithms from the transport planning used to optimize the routes. You can see 3 routes were developed. One, the green one, gray one, and the blue one. Also, some assumptions were taken to decide the frequencies of each of the routes. intermediate transfer stations were made. For example, you can see the major hub was Zurich, as obviously since it is the capital of the major populated city of the Switzerland. Once the routes were decided, frequencies were decided, how many people were traveling throughout the network was modeled. For that, you need a transport model for the country, and which has to be simulated for hours, which takes at least 2 days or 3 days sometimes, and number of simulations have to be performed, and which was here done for a month at least, and then numbers were compared whether it gives you whether it is a better to make a hyperloop or not. However, once those numbers were gathered, an actual benefit to cost ratios were calculated for both of the scenarios, as I mentioned already. In both of the cases, the benefit to cost ratio came around 1.6, you can see. Also, some sensitivity analysis was performed considering whether the cost would go higher or lower, or people would not attracted to the Hyperloop mode. Still, it always remained above the one. However, there are indeed a lot of number of assumptions. So I'm not, but I think over the years we will fine tune those assumptions and get to the actual point. And this was that was it. The number which gave you for this talk specifically, the number which was discussed previously here is something which we can look into right now and talk about it, like whether it is a positive side for a small country to make a hyperloop. So indeed, in a European level network, when we think that more countries will join, it will be much more beneficial to go for the hyperloop, depending upon the system how we design, whether we make on-demand pods or scheduled trains, like which right now which runs a scheduled. Right now, each of the countries have scheduled train timetable, but Virgin Hyperloop or Hard Hyperloop system from Netherlands also says that they're gonna design pods in a way that it will be available like a Uber. You'll have on-demand pods, and those areas of research are still ambiguous. But if we go for a scheduled one, indeed this would be much more beneficial for the society. I think that's all from my end. Yeah.
All right,
So
thank you
other
so
than-
much. Any questions?
Yeah, quick question. Other than just pulling more data from surrounding countries, is there more data that you would pull into a larger study besides the data that you had for Switzerland in this case?
Yeah.
I guess more information about the operational models from each company would probably be one. You kind of alluded to that.
So I'm not sure whether you are aware about how the transport model works for the specific countries. So each country, usually when we talk about European country, most of the countries have their national transport model. Basically, the purpose of national transport model is to look into how people travels within the country or outside the country.
Right.
Government or policymakers look into it and define few scenarios before going for a project, and check whether the project is beneficiary or not.
Right.
However, now each of the government and each of the countries have their own national transport models, and each of the countries have their different softwares and their different versions and variety of methods to estimate these things. So making them consistent would be a really challenge, I think. But there is a very important thing, very tricky thing we can use here is airport building, because I think most of the shift is gonna come from air transport. People gonna shift from airplane travel to the Hyperloop travel. So that data from the private companies or airplane operators should be gathered, and then it would be much more easier to simulate or to look into.
Makes sense. Thanks.
Yeah.
Oh, I have a question. Yeah. What types of optimization algorithms did you use for predicting the pathways for this type of network?
Yeah, so optimization process was performed in 3 phases. First was network generation, but I think you are interested in only on the route design phase. For route design phase, I used Mundell's algorithm, which is one of the oldest and widely accepted, developed around in 1983, which defines the longest, shortest path of each of the network and optimizes based on the maximum number of transfer stations. Did I answer your question, or you want me to explain more?
But no, I just wanted to know if you had used like any specific types, or you had considered other types of route optimization algorithms.
Yeah, so that's the Mundell's algorithm. Imagine there are no colors in this graph. The algorithm defines the longest, shortest path, meaning from any point to any maximum distance between any 2 points, which will give the longest points, and it will try to define the shortest path between these points. So from Geneva to Lucerne would be the longest distance in this graph, and that would be the shortest path as well. That way it was defined. Is it a bit complicated to understand, right? Hello?
Yeah.
Is it complicated to understand?
No. This is Sebastian. Morning or good afternoon, everyone, from Transpod. I hope you're doing well. I have a few questions for you, actually. It's a good first work. I looked at the last slide you presented, and you are lighting a ratio almost of 1.69, and so I guess your objective is to showcase that Hyperloop line is beneficial, so which is good. No? Yeah.
Go ahead, shoot it.
Yeah, you've mentioned 72. I think it's in billions, 72 billions in fare revenue. Can you, I would say, share with us what's the ticket price associated to that, and also the duration? Is it the fair value or the amount the consortium is supposed to get over 1 year, 10 years, 100 years? What's the logic behind that?
Yeah. So first, coming to so I'll explain you both of the scenarios. The first scenario is without fare, without fare scenario is basically Switzerland has 2 kind of subscription. The one is called GIA, which is abbreviation for general abonnement, and the other one is half tax, which means whichever ticket you buy, you're gonna get at the half price. But for that subscription, you need to pay some money yearly, and considering that so from that money, each of the transport authority will get their share according to the passenger kilometer they have approached. In considering that value, I came up with the 72.95 billions CHF for without fare scenario. Now this value is for 40 years. It is not for 1 year, from 2040 to 2079. That's how it has been calculated.
Okay.
And yeah, now when we come to the with fare scenario, so for with fare scenario is now is the most controversial thing to assume some fair pricing for Hyperloop. So what I did was, so I was looking at some high-speed rail ticketing pricing. Now high-speed rail runs around 500 kilometers or 400 kilometers per hour, and then I looked into the air transport passenger ticketing pricing, and I thought the simplest way at that moment to come up with some value was averaging out. So in that way, I could come up with 32 cents per kilometer. Let me check if I'm not wrong in assumptions.
Yeah, you can have an average price.
Yeah.
It's fine.
Yeah,
It's
that's
just
how
like
it was defined for per kilometer, and it was linearly assumed for all the passengers.
it's just like the way you did it. You have to be careful because on the ratio calculation you did, you're also putting 30 billion in time saving. So
Yeah.
that, I mean, and people tomorrow who's going to finance those infrastructure, unless it's really the government, and they, like in North America, pretty much that time saving aspect, they don't care because it's not going to be cash on the bottom line to finance the infrastructure. They say, okay, that's going to help people to save time. Yeah. It's like the time you're saving by using a Uber, you're not giving that back to Uber, just to give you a simple example.
Yeah.
So I would first remove that from your table, and then you have an infrastructure cost, which is a one-off. So when are they going to have their return on investment? Is that 30, 40 years? My point is that we have to be careful and not making numbers. You are in Switzerland, and it's not like the flattest country in the world. You have mountains everywhere, and the infrastructure cost is probably the one where it's the most expensive. And so basically, I don't trust what you've written. I'm sorry to be straightforward, but any financial institutions looking at that will tell you that doesn't make sense, that it's profitable the way it is, knowing the geography you have in Switzerland. So I would maybe focus more on how can you make the showcasing that the business model is different from a conventional high-speed rail line. How come? Because high-speed rail corridors, you only have the passenger kind of revenue stream. So look at if you mix passenger freight, how much money you're going to get from solar panels, and there's also some other models related to the real estate market. So if you had those four elements with probably you can keep maybe 50 billion. I don't know if 50 billion is really sounds like maybe right, to be confirmed, but okay, I have to spend 50 billions. And then if I had those four revenue streams, is my line profitable? And then if you have a strong model, then you can share that with government officials or financial institutions. But the ratio at 1.69, no way. No, it's not practically. Doesn't sound realistic, to be honest. But anyway, it's a good. The demand sounds like you have a good source. And then there's initial work, but there's numbers. You compare numbers which are not you're not comparing the same. So
yeah. So in usually the master's thesis are not supposed to be for the actual numbers. They are mostly focused on the methodology. In any case,
yeah, but if the numbers are not don't sound right, they can question the methodology behind it.
I'm just explaining my part. What I'm trying to say here is, like, of course, the 1.6 or 1.61 or 1.69 number doesn't make sense at all, because the case of Switzerland for the Hyperloop network indeed doesn't make sense at all.
I'm not sure. You know what? I'm not sure about that. This is where, like, you can have, let's say that you only do your analysis with passengers, and you end up having a ratio maybe 0.5. And said, okay, however, if we consider the Hyperloop model and had freight, energy, plus other revenue streams, then the line may or might become profitable with a ratio around 1.1 or 1.2. But
however, when you add freight one, the infrastructure cost also goes 1.5 times higher. Not only infrastructure cost, but the maintenance cost also goes much more higher, because when you have more heavier loads running on the tracks, or indeed this gonna have tracks as well.
Okay, but then you need to have assumptions. On the Hyperloop, for Hyperloop system,
yes,
you can choose to transport heavy loads, but what makes sense is to focus on freight which is sensitive to time. Otherwise, no point of building an Hyperloop line. You can build a conventional railway track.
I wouldn't agree completely on that, but yeah, it depends upon how you look into it. For example, they have simulated the Paris-Hamburg line, and which was much more beneficial comparing to the current air infrastructure.
But the question is your ton of wood really, and do you need to speed up the transportation of a ton of wood or iron or natural resources at the same speed of e-commerce? Like the weight of a FedEx package is not the same. Then it can fit like a Hyperloop line. And again, it's an advice, or I would focus our air travel cargo, and then you will replace that definitely.
Yeah, I agree with Sebastian on that. The cargo is not heavy load cargo. It's the type of cargo that would move by air.
Yeah.
Yeah, but I never looked into the.
No, but it's not. It's not like asking you. It's just like recommendations or comments to improve your initial work.
Yeah, indeed.
Just to make it more accurate and so on, and be careful to compare numbers, apples with apples, and that's it. Yeah. Otherwise, you may face criticism.
So that actually leads into like what I wanted to ask Sebastian, since he's the CEO of Transpod, and they just finished a really good study in Canada recently on how it would be to make a Hyperloop track in Alberta. And so I was wondering what your estimate for the BC ratio was for your track that you were trying to, or you were thinking of constructing in Alberta.
I don't know yet. So the analysis, the initial analysis we've done is just a kind of a proposal for the government with different phases, and we were really careful that's to avoid facing too much criticism, saying that in order to confirm any construction in the province, we have to confirm that the corridor is economically viable. The initial estimations we have for the corridor is between 6 to 10 billion. And this is for 300 kilometers. But then again, it goes down to, okay, you have to confirm the different revenue streams. And we're confident about that. There's enough ridership. And the corridor, again, it's not Switzerland. It's flat, it's straight. There's nobody between the two cities. So it's kind of an ideal candidate. But and the full feasibility study, we're starting to work on that, and will be released next year. Don't know yet if we're going to make it public, but this is a document required to attract financial institutions to finance that. And they are really, I mean, the level of expectation is high, really, really high. So it's really detailed study, infrastructure cost to the bolt, like how much they want to, their objective, this is, we're talking about financial sector, it's to mitigate the risk. And as you may know, we're developing a technology which is unproven yet. And it's already a huge risk for them to engage. So they will look at backing up that big times. So yeah, so that's the plan for the next 6 months, 12 months. But interesting indeed.
Yeah, definitely sounds like some interesting work. And for for like people who are for students who are working on propulsion systems, I know that Transpod's propulsion system and what you're trying to do is a bit different from Hyperloop ones. Is there anything in particular that you wish more people were studying, especially in terms of when it comes to building a full-scale Hyperloop, that you wish that you could, and the team at Transpod could look into more, but maybe didn't have the time or the ability to, and feel that should be important in this industry?
Well, first of all, I think at the beginning, the system between Virgin and us was really different. Now I have a feeling that it's kind of converging somehow. One key aspect people should know is that, and that was our key assumption at the beginning, it's to keep the infrastructure as basic as possible. So how can you make it cheap? Because even when it's cheap, it's not cheap actually. And still today, I think this is the choice. Hart Hyperloop in Netherlands is going now. If you're going with maglev, you're kind of multiplying several times the initial cost of the infrastructure. So we kind of put it maglev aside right from the beginning. And there's also something key you can test, is that the air is conductor at low pressure. So if you have electromagnets in the tube with high voltage, it's just a fireball in the tube. And from a maintenance standpoint, it's just a nightmare and it's not practically feasible. So you need to move away from that. And how can you design a propulsion system without using maglev technology? Or it's still magnetic, but without electromagnets on the track. And so we've seen many things like, this is one of the options Musk pushed in 2013. So he was proposing air bearing. So now air bearing, people realize that it's kind of tricky to make it work. I think HTT is kind of using passive levitation, which most of the students have used that too as well. And then it goes down to linear induction engines. So I think now people or companies are developing those engines, but doesn't address the levitation aspect. So how can you make it levitate if you want to have, without using electromagnets? So something to understand is that magnets got two functions. They can repulse each other, but they can attract each other too as well. So if you use the second aspect of the magnetic system or component, you can, with a steel tube, you can play around it. But the propulsion system, is, so you have linear engines, magnetic rails too as well. If you choose the solution from Musk having, I would say, on a at regular intervals, you have a boost of acceleration. The boost is also an issue because from an operation standpoint, if the lines stop and you're not exactly aligned with that, I would say, acceleration system, you're stuck. So it's not good too either. So you need to have a continuous approach too as well. So those are the key figures. We've worked around it and regarding our technology strategy. So those are kind of recommendations. Avoid high voltage stuff inside the tube, because when the environment is conducting electricity, this is not good. So yeah, that's pretty much what I can say around that. And the engine, you can look at what's been developed for the SkyTrain in Vancouver. It's the train connecting Vancouver airports to downtown Vancouver. And so this is an engine developed by Bombardier. They have a reaction plate. Some of the work anyway, some of the students' team have been doing. But the efficiency of that is not that great too as well. So there's work to be done.
makes sense. I think Kirk McGregor, you had a question?
Yeah. I wanted to ask if there had been or is planned to be a cost risk analysis of the value of time sensitive, if not emergency, transport for the maximum extent of a possible line over the risk to some deterioration or damage to, let's say, categorically environmentally sensitive area that might be designated by a government and or organization. And I say this because, you know, I want to know if a Hyperloop line could actually live up to a promise of having a lower impact compared to some other mode of transport, and it could be able to deliver upon that, but in some risk adverse way through prudent, let's say, underwriting of some portions of the line, and possibly with like greater underwriting over environmentally sensitive portions for whatever the catastrophic effects might be, because someone might be prompted to use the line in, let's say, an emergency transport situation of some type of valuable cargo, living or non-living. You know, at that point, the cost might be comparable. So I was just wondering, like, if you've done that or are planning to do that.
I'm not sure. So is the questions to about risk analysis regarding the environmental impact of the line? Is that, or
well, the
like
use of the line? Well, not just like of the line, of the use of the line for specific types of cargo, time sensitive and or emergency cargo. An emergency may be living or non-living cargo. And if that was something you were doing for, you know, possibly the Canadian government, or would you be in a position to be able to do that?
Yeah, we more than the risk analysis is the question is, did we identify potential, I would say, use cases to transport sensitive goods? Is it better reframed?
Yeah.
Or, yeah.
Well, yeah, or would you be like planning to do that? Like,
I mean, even before doing that, it's to identify if there is some demand for such a sensitive product.
I could think of a couple.
Yeah, we had some conversation. Like one of the benefits of an Hyperloop line, like between Calgary and Edmonton, or even between any cities, it could be used to transport human tissues, like organs and so on. Like today, just as a practical example, there is medical facilities in both Calgary and Edmonton, because in order to, when they transport some of those items, they have to, I mean, because of the sensitivity of the product, they need to have some specific facilities and because of the time difference to transport those items from one city to another, they need to duplicate some of the facilities. So an Hyperloop line could allow that. Same for the freight, like it could save them some cost by reducing some of those facilities, or they may not need them anymore because they can ship it quicker than today. Is that answer your question, or?
Well, yeah, and pardon me, like if I missed you explicitly saying this. So, do you think it would also be useful for medical isotope transport, for you know, between hospital networks and or their like isotope suppliers for, you know, tracers or decontamination or some other advanced medical application?
Yeah, I think so. We could have, I would say, medical pods to evacuate people, or even to do the main question which remains is the last mile, I would say, because the line won't be connected directly to the hospital. So you still need an ambulance to pick up whatever the pod will bring at the final destination. So the question at the end is, would the medical pod would be more efficient than the helicopter? Because the helicopter usually will land on top of the hospital and can carry, but probably less expensive. So we need to do the math. For now, there's an application. It's not the main one, so not like our main priority right now, but in the future, for sure.
Makes sense. Makes sense. And so we have a very interesting set of people today, in that we have you from Transpod, we have Kalrav, who is working with the Swiss government, as well as Strathloop, as well as Vivek from DGW Hyperloop. So definitely a few organizations that are working on feasibility. So I would really love to hear from first from Sebastian, then from Kalrav, and then from Vivek. How has it been working with these governments? Have they been pretty helpful in providing data and working with you guys on trying to build out this idea, or are you doing everything on your own and you put out papers like this periodically and hope for the best? What's that relationship formation kind of been like?
And,
I guess
Kirsten as well,
yeah.
if you have any input as well, Kirsten.
So until now, we've done that mainly with our own data, or look at what's available online. Sometimes we had input from governments, but the data is not always up to date. That's the first time with the Alberta government, where they will really open their books and we'll see what they have. But I think we'll have to update most of it. It's probably too old, or it's probably from we've looked at some of them, it's from 2014 or 2017. So we'll need more updated ones. Yeah, so that's this is where it is now. So yeah, and governments, they are yeah, it takes time. It takes time. It took us almost 4 years to get that MOU. So you have to be persistent, and 2 governments. So anyway.
Kalrav, did you want to comment on this with Switzerland?
Yeah, I mean, in my case, I was mostly connected with ETH, so it was readily available. But as already Sebastian mentioned, that the data, if you get the data, you still need to half of the energy you waste on preparing the data, because you need to sort it, you need to organize it, you need to filter it, and when you can actually work on, you already half of your energy is drained. So it's always a tricky one. But while the journey, you see a lot of pessimistic people. In my case, I also see a lot of pessimistic people don't believing in case gonna happen or not. But yeah, that's all.
All right, Vivek, how about with you and the Madhya Pradesh government?
Vivek is gone.
Okay, well, if you're here, Vivek, please definitely let us know in the chat. And then, yeah, Kirsten, I know that you're not necessarily on the team that does this planning, but how has it been recently with, I know that Hyperloop One has worked very closely with the US government, especially now with Elaine Chao and the Department of Transportation being very interested. How has the relationship been?
Yeah, and actually I work really closely with the US government side of things on the US projects team. So I'm really familiar with those pieces of things. Luckily more peripherally familiar with the international work because there's been some headaches on that side. I think Sebastian nailed it. It takes time. Government is not a notoriously fast moving group of people, but we've been pretty pleased that the work that Virgin Hyperloop and others have done at the US government level with the Federal Department of Transportation has actually moved really well. And we've worked our butts off in DC, spending a lot of time talking to a lot of people to make that happen. It's all a very manual process. I don't know if anybody has seen Congress trying to operate remotely during the pandemic. It's pretty entertaining. And it just gives a sense of kind of how things work in the US government in particular. We're not very fast moving, but the progress from the creation of the Net Council to Secretary Chow releasing the guidance document that was released about a month ago here was, I think, 20 times faster than high-speed rail's similar progress. So we're certainly set up on the right trajectory. In Europe, things are moving along at a steady pace as well. So I think hopefully the progress in the US will feed the progress in Europe, will feed the progress in Asia, and the entire world will kind of pick things up. But it is a lot of time really educating people about the technology. I'm sure everybody on the call who has spent any time talking to people about the technology has had to say, no, I don't work for Elon Musk, actually. It's still one of the most popular questions we get. So it takes a lot of patience and a lot of effort and a lot of conversations, but we are seeing good progress.
Do you have any recommendations, Kirsten, for university students with an engineering background as yourself in trying to do like science and technology outreach to politicians that might not have a background in that or their staff members?
Yeah, that's a great question. I mean, I think that this is a good group of people that I think the more of us that talk to politicians, their staff. And what I found is getting to the politician is a big deal because they're the one who's actually doing the voting and making things happen, but their staff really does a lot of the work behind the scenes. So we've found that interacting with the staff is a really good way to do things. There's a lot of less direct ways to kind of get involved. But I think just going out and talking as much as we all can about Hyperloop and kind of educating people about the industry so that it goes more towards a real thing than the kind of science fiction world that everybody thinks it's in. And whether that's, our peers or our parents or, politicians, I think there's all levels of education. And what we as the businesses in the industry are working on is really building more stuff so that we can show everybody that this is real and kind of sprinting towards commercialization as fast as we can safely do. Because that will just progress the conversation. So I think that, talking about it all the time to anybody who will listen is basically a big, huge help.
For sure. And then for Strathloop or any other student teams on the call, like, how has your experience been with talking to your local elected officials? Have you been able to have a discussion with them about Hyperloop or funding Hyperloop or doing that kind of work, or not really at that stage yet? What's that been like?
For us, obviously, the political scene is about out with our reach as a student society. I think we'd love to be there in the years to come, but at the moment it's kind of more focusing on sort of internally within the university. And obviously we kind of have the advantage in that sense that the people that we're speaking to in charge of departments are still sort of technically minded people, so that does make it slightly easier to sort of explain things. But yeah, certainly would mirror some of the comments that Kirsten made there, just about explaining things to people and making people realize that the technology is real. It's something that can really genuinely benefit the world. And I think a very similar methodology as well. Just talk about it as much as we can, putting stuff out there. I think projects like what we've done with the Airlock stuff and the scalability projects on our team side really kind of help within the university paint a picture of what Hyperloop is within Glasgow. So that's sort of our experience.
Okay, and then yeah, like one last question for Kalrav, Sebastian, and Kirsten on work that you've done with feasibility. So how do you kind of weigh the benefits of that the Hyperloop would provide a certain place or a certain like area of society versus the support that the government or like businesses in that area are providing for your Hyperloop development? Do you go for places that are you kind of like have a mix of those, or try to go for one more than the other, or what do you look for in these? Because I know that especially with Hyperloop 1 and Virgin Hyperloop, like you did that whole mapping competition a couple of years ago to kind of figure that out, and just wondering what those characteristics were.
Okay. Sebastian, do you want to go first, or do you want me to go first?
Go ahead.
I'll jump in and basically say that it's there's not a single answer to that really that we've found. Part of what we've really been focusing on is, you'll notice if you look at where our projects are, we'll take the US as an example. We're not really looking seriously at Los Angeles or San Francisco or New York. I think a lot of those big cities, they have so much else going on that they're not really focusing on the benefit that Hyperloop can bring to their region. We've found the more mid-sized cities or the centrally located cities that aren't these mega regions or mega cities to be a little bit more focused on what the Hyperloop can really bring to benefit their region. So I guess the first piece of this is a lot of the places we're working with are not places that we have gone and solicited work with. They have come to us saying, hey, this is exciting, we'd like to be a part of that. And that's really important because there's so much work to do between here and the commercial release of the product. So we can't drag Los Angeles along with us as much as we would love to, that being where we're based. Dragging them through the process from the R&D work to the commercial product is going to be extremely painful and probably won't work. But places like Missouri, like Ohio, like Texas, like North Carolina, they've all come to us saying, hey, we see this as a really helpful, exciting solution. We'd like to be a part of it. In India, our work in Maharashtra has been similar, that group of people. And actually, that's a little bit of a unique situation because we're connecting to Mumbai. Obviously a pretty big city, dwarfs any of our big cities in the US here. So I think the biggest piece really is working with places that are enthusiastic about new technology and enthusiastic about what Hyperloop can do as kind of a step change for their region. And that's really proven very fruitful for us. And then every individual corridor and alignment is its own unique feasibility study. So some of those corridors look more attractive than others. It's certainly a mixture of freight and passenger movement on each one of those. And some, there's really interesting business cases, there's really interesting partnership opportunities for businesses in the region. And some, there's less so, but there may be more ridership. So each one is really an individual assessment.
Yeah, I fully agree with you. The key aspect is to find a sweet spot, and the most important, I would say, element to have is interest and demand. But demand, not the demand of the corridor, but
Right.
Interest from those mid-cities. So you need to find a sweet spot where the interest comes from, mid-sized cities where you're confident that there's enough ridership to justify such infrastructure. And like Kirsten said, where like in Ontario had the same proposal as the one we did in Alberta, and they're not as interested because they have other industries. They're not as desperate as Alberta. And what I would like to say as well is that COVID is kind of a growth factor for us. It's kind of anyway, from what I've seen, it's accelerating our development. The fact that we signed with the province of Alberta is also, it's a consequence of the fact that the oil barrel is fairly low. It's probably similar in Texas too as well. I guess they start to see, hey guys, we have to diversify the economy of the province of the area, and Hyperloop can contribute to it. So yeah, and I don't know if you saw that, but Europe as well is proposing a resolution. So, and the next big event which will face it as humanity is called climate change, and it's coming fast. And Hyperloop could be a real good solution to replace short-haul flights, and yeah, and remove some of those carbon emissions. So yeah, it's kind of sad in a way that we need always to face the wall to change, but that's how human are, myself included. I mean, we change when we have no choice. But anyway, let's be ahead of the curve and try to move on that. So I'm pretty optimistic with what we do. Definitely, the speed is increasing, so it's nice.
Okay, and then Kalrav, if you wanted to kind of give your perspective on how do you weigh that, and you kind of did this in your paper as well, like the economic benefit and the benefit to the people who are there versus the incentives that are being offered by the government or by certain businesses in certain areas, in terms of determining where you would want to put a Hyperloop route.
So coming back, coming from the background of transport planning, I would say like any mass transit mode is always justified in terms of social benefit or societal benefit, or I would say extending adding to what Sebastian already said. I would say when it comes to any line, any pair of the cities of second tier city and the first tier city, having distance of more than 500 kilometers and between 500 kilometers and 1,000 kilometers would be justified for sure, I think, for Hyperloop, because it would bring down the travel time to the 1 hour around, and people would be easily go for work to the bigger cities on the same day and coming back to the home. So that would be justified in any case. In my thesis, I didn't consider any positive or societal aspects like creating jobs and kind of stuff. So that would be much more employment opportunity and the recreational and real estate value. So there are larger benefits which are any even given public transport mode gives to the society, which are difficult to evaluate as well. So there are a lot of benefits, I would say. Yeah.
I've got a question for both Kirsten and Sebastian, and it's apologies if it's slightly cynical, I don't know, but what do you think is the biggest thing currently holding Hyperloop back?
For us, it's easy. It's access to capital.
Just investment.
Yeah.
Yeah. I think that's a big one as well. I think that is probably the biggest one. Closely behind is still that, the Net Council guidance in the US here is a big step, but there not being a regulatory framework, I think, is part of what makes access to capital challenging. But, a reason in the US we have no high-speed rail. We have a few projects we're working on, but there's not actually a real system. And I think it's because it's too hard for states or the federal government to get behind spending so much on a project, and this is how much large projects cost. Hyperloop is not, it's certainly in the same ballpark as high-speed rail and likely cheaper on the same corridor, but the idea of spending billions of dollars on a project is just hard for governments to grasp sometimes. So bringing in that funding and financing and kind of getting everybody's mind wrapped around it is challenging. That's, our intent is to basically progress the technology ever further commercially and pull along the investment as we go, but it's certainly not a sure thing.
Of course, yeah. Thank you for that.
For us, it's slightly different. So it's access to capital. Having said that, our strategy is not to request that amount of funding from governments, but just to to get it from the private sector. But the private sector from our side will know. I mean, I invite you to ask me the question next year. We'll see how it goes with the Alberta project. But some of the main feedback we receive from those financial institutions is that, okay, you may have a great technology and so on, but you need to confirm that there's a market, because if you can have the best techno, if there's no market, you're screwed. And so they wanted to see that kind of agreement with a government to move ahead. The big question mark now is it going to be enough for them to move ahead? They're pretty much risk adverse, so same as governments. So this is where the full feasibility study we're moving ahead. And to come back to the comments discussion we had with Kalrav, it's really about confirming that an infrastructure can be profitable. That's the key aspect, because 80% of high-speed rail line in France or in Europe or anywhere in the world, 80% are not profitable. And so, and then there's different approaches. Governments in Europe are saying, yeah, but there's many side benefits, so we're okay to finance that. But the private consortium won't do, and they don't care. They don't give a shit about that. So they say, okay, bottom line, is it making money? So if it's not making money, I mean, we're not interested. So that's the key point to confirm.
Of course, yeah, money makes the world go round after all.
Yeah, even so, in addition to that, the good news is that even with COVID, many central banks printed bills. So there's lots of liquidity on the market. But it doesn't mean that they're giving blank checks. There's still, so the only aspect it's giving us is that they're more willing to take early stage risk. However, they're still looking at what's the return, how much money can I get out of that, and what kind of guarantee I can get. So that's the, anyway, so we keep going, and hopefully we should be able to confirm that soon.
Excellent. Thank you. Yeah, so neither of you sort of mentioned technical challenges, so I suppose my follow-up would be that do you feel, or do both companies feel, that fairly sure of the sort of subsystems and the concepts that they're using at the moment? Do we feel like the concept itself is cracked, I suppose? Or is there still technical work to be done?
And just because financing is the hardest part doesn't mean that there aren't other difficult parts.
Yeah.
Yeah, I think we've come quite a long way in our tech development, and we still are, regularly finding, as you get further into the detailed design, you find little difficulties. There are a lot of pieces about it that are very challenging. I mean, you guys hit on one with the air dock design. It's not a straightforward selection, and there's a lot of choices that we've made, and I think that need to be made when working through the process. That you can choose a simpler way that's not as economical and not as good of a business case, or you can choose a more complex way that's maybe riskier and harder to design. And so we've chosen one or the other in a lot of cases, and lots of technical challenges still, but I don't think there's any barriers that we've found.
Same for us, yeah. So pretty confident. And on the regulatory framework, even if it doesn't exist yet, the fact that the US and Europe are moving ahead, we'll have to accelerate the pace on that for sure, but it's getting there, so step by step.
If it was easy, it would be boring, right?
Yeah, exactly. It wouldn't be worth it.
We won't do that.
Excellent. Thanks, guys.
Sure.
And I think just one last closing question, just because I'm pretty sure you've faced this before. Pretty sure both of you or your companies have received tons of emails from student teams being like, hey, we're X name student team from X university. Can we please get some funding to help us develop this? So my question is, what are some tips that you would give universities? What are some funding resources or places do you think that they should maybe look at that they're not considering as much, that you feel might be more fruitful than just emailing you guys and seeing if they can sponsor?
Well, for us, it's hard for us to sponsor things because we're out there chasing funding constantly ourselves. Developing a Hyperloop is not inexpensive, as I think everybody on the call knows. I would say probably, I mean, there's a lot of companies that are more established that I think, maybe are in the realm of competitors for Hyperloop technology. And some are realizing that this is a technology that's coming and that they should get involved now. It's not always clear who those are, but those might be some of the good ones to reach out to, the people who have a big R&D budget. Our entire work is really still a lot of R&D, so there's not a separate set aside R&D budget that we can dedicate to things like that. That being said, we're working on what university partnerships might look like and sponsoring grad projects and those types of things. And we're not quite there yet, but I think it's coming in the next few years.
Yep. So it's kind of same for us, and I think student teams have done a great job. If you're talking about the competition hosted by SpaceX, yeah, many universities succeeded, or many teams succeeded to have some sponsors from well-established companies, and that's the main strategy as we speak. So COVID doesn't help for sure. Many budgets are shut down, but I don't know. Is there any? I didn't follow recently, but did Musk announce anything for next year or nothing? Doesn't want to do it anymore.
Looks like we have to pick something up, Sebastian.
Yeah. Yeah, we'll have to organize something. Anyway.
Yeah, we'll talk offline.
Yeah, a conventional sponsorship, the same way you want to sponsor a sport event or any events, is probably the best way. And there's definitely companies interested in the sphere, which more than willing to invest in Transpod or Virgin would like to have a small budget for a student team. So anyway, it's not the same range of investment.
Right, then lastly, to Kalrav, the same kind of question was, because you did your master's thesis on Hyperloop, how is the support, especially at Delft, being that Delft Hyperloop team is like very world famous and Hyperloop is also world famous? How is the support for doing Hyperloop related work for masters?
So the thing is, the teams usually work on the more on technology aspect. They don't look into the network aspect or the feasibility aspect. They either work on the propulsion system or achieving the speed of 1,000 km/h acceleration kind of stuff, rather than looking into the planning or policy kind of aspect, which I looked into. So the support, to get a support from there is really difficult, and usually these students are from the bachelor's. Very less students are from the masters, so that kind of a bit a tricky one, but yeah, that's the challenge for them. So and indeed, like, I wasn't connected to any Swiss Loop team or Delft Hyperloop team. I tried to approach a lot of times to them, but being the outsider and policy level thinking, it doesn't fit to the propulsion kind of stuff and technological aspects.
Makes sense. Yeah. All right. Well, I think it's already 5 o'clock. So let's end that for today. Thank you everyone for coming. Especially thank you so much to Kalrav and Kirsty and Bradley for presenting on all of the amazing work that you're doing. So Bradley and Kirsty's papers are up on our voting page on our website. In case anybody wants to take a look and review, I would really recommend that, because it really helps these teams grow and continue to work on improve their work. So please take a look at that if you have the chance. And basically what happens, the way we set up our events was Saturday we have these kind of panel lightning talk sessions, and then Sundays we have like more in-depth discussions that is more specific to the technology development, how we can actually work together on this. So last week it was really, really great, because we had a very nice discussion on how to work with very high voltages in power systems, and how we can work on control systems together. And so I'm hoping this week we can have a similar discussion tomorrow with the feasibility portion moderated by Kalrav and the energy session moderated by Bradley and Strathloop. So if you're interested in continuing the discussion, please come because it's definitely led to some new collaborations and some very interesting work. Again, also thank you so much to Sebastian from Transpod and Kirsten from Hyperloop 1, Virgin Hyperloop, for coming and advising this session as well. It's been a pleasure to speak with both of you on this subject, and I hope that you had a good time to learn some things from the student teams. So with that said, thank you everyone. Please, let's continue this conversation on Slack and over email, and hope to see a lot of you tomorrow.
Thanks all.
Thank you.
Thanks, Marth.